This is a video on verifying Stokes' theorem. The question states, verify Stokes' theorem with the vector field f of x, y, z is equal to 4zi plus xj plus xyk. And the surface is defined by z equals 1 minus x squared minus y squared for z greater than or equal to 0. So let's sketch that surface. Z equals 1 minus x squared minus y squared is a paraboloid, and z greater than or equal to 0 tells us we're above the xy plane. So there's my surface, and I want to verify Stokes' theorem, so recall that Stokes' theorem states that the line integral over the boundary of a surface, which I'll call C, of f dot dr is equal to the surface integral over that surface of the curl of f dot n ds. So we need to verify Stokes' theorem, and that means calculate the left-hand side of Stokes' theorem, calculate the right-hand side of Stokes' theorem, and show that they're equal to each other. So let's start with the left-hand side. I'm taking the line integral over C of f dot dr. Our C is the unit circle in the xy plane. So it has parameterization. R of t is cosine of ti plus sine of tj. And since we're in the xy plane, the k component is 0. So let's find r prime, and that's equal to negative the sine of ti plus the cosine of tj. So we need to calculate the line integral over c of f dot dr. T is the angle that goes around the circle, and we're going all the way around. So t goes from 0 to 2 pi. And we have f. F is 4zi. The z component is 0 for this curve. So we get 0. And then plus xj. X is equal to cosine of t. So there's the cosine of t. Plus xyk. Y is the sine of t. And x is cosine of t. So we get cosine of t times the sine of t for the k component. So then we dot that with dr, and dr is negative the sine of t, comma cosine of t, comma 0. Then I take dt. So I take the dot product. I get 0 plus cosine of t times cosine t, which is cosine squared t, plus cosine t sine t times 0, which is just 0. So I'm just left with the integral from 0 to 2 pi of the cosine squared of t dt. And that's not too difficult an integral. I worked that out, and I got pi. So now I need to show that the right-hand side is also equal to pi. So we need to calculate the surface integral. And to do that, I have to find the curl of f, which is the determinant of the matrix, ijk, del over del x, del over del y, del over del z, 4z, x, xy, because that's our vector field. So the I component is del over del y of xy, which is just x, minus del over del z of x, which is 0. X minus 0 is x. So I get xi. Then I subtract del over del x of xy, which is y, minus del over del z of 4z, so minus 4 times j. And then for the k component, that's del over del x of x, which is 1, minus del over del y of 4z, which is just 0. So I just get k. So there's the curl of f. I need to find the surface integral of the curl of f dot n ds. And since s is defined by a function z equals 1 minus x squared minus y squared, n, which is the upward pointing unit normal vector, is negative g sub x, comma negative g sub y, comma 1. G sub x is negative 2x, so negative g sub x is equal to positive 2x. G sub y is negative 2y, so negative g sub y is positive 2y. and then the 1. So I take that dot product. We get 2x squared. Then we have 4 times 2y is 8y, minus y times 2y is minus 2y squared. And then 1 times 1 gives us the plus 1, dA. So I need to integrate this over the region, and the region is the unit disk. So it's easier to use polar coordinates here. So then the unit disk has theta goes from 0 to 2 pi, r goes from 0 to 1, 2x squared is 2r squared cosine squared theta, 8y is 8r sine of theta, then minus 2y squared is minus 2r squared sine squared theta, plus 1, and then dA is r dr d theta. So I worked this integral out. It took a lot of work. I multiplied the r through and then integrated it out, and what I finally got was this double integral is equal to pi. And that's what I wanted, because I showed that the left-hand side equals pi, and I showed the right-hand side of Stokes' theorem equals pi. So that tells us that the left-hand side of Stokes' theorem equals the right-hand side of Stokes' theorem for this example. And I have verified Stokes' theorem. And I'm done with the problem.